Okay, so as you have probably guessed right now, we're starting the second part of 11.2. We're going to be solving these systems by elimination, which I happen to much prefer over substitution, and I think you will too. It's a lot faster. There's some strategy involved, just like there was in substitution. We had to kind of look at the field and decide what to do, and it will kind of follow the same way when we do elimination. I have selected some of the problems from your homework assignment already. So you are assigned problems 1 through 6 on the homework. I'm going to work number 1 and 3 with you. If we have time at the end, we'll come back and do another one, but I think we'll start with these. I'm starting with number 3, and then we'll go backwards and do number 1. So if you want to write this one down, see if we can get that big enough to see it. Okay, one of the most helpful things that we can do when we're working with a system of 3 equations, in order to stay organized and keep them straight as what I'm doing with them and which equation I'm talking about, I think it's really helpful to label them as equation 1, equation 2, and equation 3. So if you'll number them, that will really help you understand exactly what equation you're using and what you've already used. Okay. So step 1 on your how-to instructions, it said pick a pair of equations that will allow you to cancel a variable. So if you're looking at these equations, you need to pick 2 of them that when you add them together will allow you to cancel a variable. Can you see any 2 that might work? 2 and 3. Okay, so she said, let's pick 2 and 3. So the way this works is we write out equations 2 and 3, and we're going to stack them, and we're going to add them, just like we did when we were dealing with systems of equations in 2 variables. Okay, so we have negative 5x minus 5y plus 5z equals 5. And then for equation 3, we have 2x plus 5y minus 3z equals negative 10. And the moves we can make here, remember, we can always multiply. If we need to multiply an entire equation by a number, we can do that. We never want to divide an equation by a number. Dividing is never a friendly option. We could always multiply, and then once we get what we want, we stack them and we add them. We don't ever subtract. We're always stacking and adding. So when we do that, negative 5x plus 2x makes what? And our whole goal here was to cancel a variable. We canceled the y's. Negative 5y plus positive 5y makes a 0. So those cancel. And then in our z term, we have 5z minus 3z. What does that leave? So plus 2z, 5 minus 10. Okay. So I have a new equation here in two variables. I'm not able to cancel anything out of this equation. I cannot solve it yet. Call this new equation, equation 4. Okay. I'm going to quickly go back to our how-to stuff. The first how-to thing says, pick any pair of equations and solve for one variable. Pick another pair of equations and solve for the same variable. So we need to pick another pair of equations here that would allow us to cancel that same variable. 1 and 3. If we pick 1 and 3 and we stack those and add those, we will be able to cancel the same variable. It's important that we're canceling the same thing. If we cancel a different variable here, we're kind of spinning a loop, and you have a hard time getting out of a loop once you're in one. So we want to make sure that we're going after that same variable again. So stack them and add them. What do you got in x? Negative x plus 2x. 1x. Cancel my y's. 1z minus 3z is negative 2z. 17 minus 10? 7. Call this equation 5. Okay. Now, go back to your how-to. It says you have created a system of two equations in two variables, two unknowns. We just did that. We have x and z left. Solve the resulting 2 by 2 system. So we just made two new equations in two variables, 4 and 5. We can solve that little system by stacking those equations and using elimination again. And it just so happens that these have opposite coefficients with opposite signs already. If they didn't, you could do some multiplication here to make that happen. So you're stacking equations 4 and 5. What are we eliminating this time? Z. 2z minus 2z. Z's are gone. And so what do we have? Negative 3x plus 1x makes negative 2x. Negative 5 plus 7. So we can divide by that negative 2. And what's x? We already have one of the pieces to the puzzle. So what can we do with that? Substitute it back in. Plug it back in. You can either go into equation 4 or 5. It doesn't matter which one of those you pick. You don't want to go back into equation 1, 2, or 3 yet because you still have two variables out and that won't help you. So you want to go back into either 4 or 5. Which one? 4 and 5. Mixed review. How about 5? Into equation 5, I'm going to put negative 1 for x minus 2z equals 7. That means I add 1 from both sides. Negative 2z equals 8. Z must be negative 4. Now, pick equation 1, 2, or 3. Which one do you want? Say it louder. 1. So into equation 1, we know x is negative 1. So I'm going to have negative 1 minus 5y plus z, which is negative 4, equals 17. Now that I have both x and z figured out, we can solve for y. 1 minus 4 makes me have a negative 3 minus 5y equals 17. Do y'all agree? Yes, Armando, we agree. It's great. Negative 5y equals 20. I get y equals negative 4. So our ordered triple there is going to be negative 1, negative 4, negative 4. I feel like this is much more straightforward. Is it all right?
Yeah.
Okay. All right, so let's go backwards one step and do number 1. And you can write it down, and then we'll get going. All right, so we want to make sure that, again, we've got them labeled equation 1 and 2 and 3. And the idea here is the same. You want to pick a pair that are going to allow you to cancel a variable. 1 and 3 or 2 and 3? Let's do 2 and 3 first.
1 and 3 is gonna cancel.
Ooh, that's nice. So what? 2 and 3. Let's do 2. I already wrote 2 and 3. So we're gonna go there. It'll be a wash. It'll work out. So number 2 has 4x minus 5y plus 4z equals 19. Number 3 has x plus 5y minus z equals negative 20. If we stack those and add them, what cancels? The y's. So 4x and 1x is 5x. 4z minus z is 3z. 19 minus 20, negative 1. Okay, so we're going to call that equation 4. Life is good. We did it. And you said our other option was to stack 1 and 3. Why would I not want to do 1 and 2? They wouldn't cancel. I'd have to fix one of them to make it work. And I want to do the least amount of work possible. So let's try 1 and 3. Negative x minus 5y minus 5z equals 2. And then positive x plus 5y minus z is negative 20. This is what I call a golden nugget kind of situation. Sometimes you just win a little bit, right? In this case, when I stack them and add them, what happens? I get to lose the x's and the y's. Bonus points. So what's left? Negative 6z is negative 18. And so what? Divide, and z is now 3. Bingo. So now what can we do with that 3? We can go right into 4. That's so helpful. So in equation 4, we've got 5x plus 3z. And instead of z, I'm putting a 3. And we're able to solve right now for x. And we don't have to do that secondary elimination step because we were able to eliminate 2 variables at once. That won't always work, but when it does, it's sure nice. I get x to be negative 2. Do y'all agree? And then what? What equation do you want? I would say 3 as well. What I look at is which one is going to make me do the least amount of work. And that y has a positive coefficient. That feels easier to me. So I've got x plus 5y, this is equation 3, minus z equals negative 20. X is negative 2. We're solving for y. Z is 3. So I got negative 2 minus 3. I'm going to call that negative 5 plus 5y equals negative 20. Now what? Add 5. 5y is negative 15. Y is negative 3. So my ordered triple here is negative 2, negative 3, positive 3. Somebody asked yesterday, does it matter what order I put those in? Yeah, it should be alphabetical. That's why we call it an ordered triple. It does matter what order.
Whenever you first plug it in, like the Z,
Uh-huh.
so it always has to be either equation 4 or 5, right?
Mm-hmm.
Okay.
Yes, because if I go back into 1, 2, or 3, I only know z. So then I'm still going to be missing 2 variables. I want to go back into 4 or 5 once I've solved for one of my variables so that then I can get the other one. And then we can go in. You got to have 2 out of 3 before you can solve for the third one. All right, the next example comes from your textbook. This is example 4 in the textbook. This one's not on your homework, but it's worth doing. This is example 4 in your textbook, so you can write it down. Bless you. So the question was, do we always cancel the same letter? No. Pick any two equations to cancel any variable that you're able to do. So what do you want to pick in this one? 1 and 2? Okay, so 1 and 2. And when we stack and add equations 1 and 2, what cancels? X. So what's left?
Negative y minus 4z equals 7.
Okay, negative y minus 4z equals 7. Call that equation 4. Now what? We got to cancel x's again. 2 and 3, but I'm looking up here at 2 and 3, and I don't see opposite coefficients. That's allowed. Okay, don't forget that. I can multiply all of equation 2 by what? By 5. If I hit the whole equation and multiply it by 5, I could create a situation where it would cancel. Okay, so my new equation 2, once I do that, is going to be negative 5x plus 10y minus 25z is equal to 15. Remember, you got to do both sides. Otherwise, you're not allowed. That's an illegal move. And we want to stack this one. This is a new 2, and we want to stack with 3 or pair it with 3. Now my x's do cancel. 10y minus 13y. Good, negative 3y. Negative 25 plus 13. Negative 12z. 15 plus 8. Call this equation 5. Now, equation 5 and equation 4 are able to stack, but I'm not canceling anything yet. What do I need to do? Multiply what? Multiply 4 by negative 3, which is going to create a positive 3y and a positive 12z and a negative 21. So what happens? Yeah, because I'm going to cancel my y's and my z's, and I'm left with this situation where 0 is equal to what's on the right side? 2. And so I have to read that. I lost all my variables, and I have to read the situation. 0 equals 2. True or false? False. And because it's false, we say there is no solution. That means that these planes don't ever, all three, intersect in one place. No solution. So they're parallel. Maybe 2 of them intersect and the other 2 intersect, but they don't all 3 intersect. We looked at pictures when we first started this. Okay. All right. This one is going to be, I think, example 5 out of the textbook. Go ahead and write it down. All right, so make a judgment call. What do we think we might want to try to cancel? The 1 and 3, and what are you canceling if you do 1 and 3? Y's. Perfect. Perfect. That was quick. Y'all caught on to this pretty well. So if I stack 1 and 3, I'm able to see opposite signs with the same number, same coefficients in y. So we cancel y. That leaves me with 3x minus 2z equal to 0. Does everybody see where we are at this point? Pretty good? Now we've got to attack the same variable again. And I already did 1 and 3.
1 and 2.
Okay? That's a different thought. I didn't have that thought earlier. 1 and 2, she says. 1 and 2 would cancel if what?
Multiply by 2.
Multiply which one by 2?
The 1. The top.
Multiply the top one by negative 2. If I multiply the top equation by negative 2, I can create the situation that I need. It's got to be a negative 2 because on equation 2, I've got a positive 2y. So if I multiply the top equation, my new equation 1 is going to be negative 4. Whoopsie. Negative 4x squared. Oh, good grief. Negative 4x minus 2y plus 6z equals 0. Do y'all agree with that, or did I botch it completely? It's all right? Okay. Goodness. And then what do we do? Equation 2? Is that right? 1 and 2? 4x plus 2y. Oh, minus 6z is 0. What happens here? Everything cancels. We lost it all. So what's left on the left side? And what's left on the right side? True or false? True. So this is a case where it's the same line or the same plane. They intersect everywhere. So how many solutions? Infinitely many solutions. All real numbers. Yeah. Infinitely many solutions. Anybody remember what kind of system this is called? Starts with a D. Dependent. Yeah. This is a dependent system. Dependent system. If I could draw in 3 dimensions, I would show you what it looks like. But suffice it to be like this. Any questions here? Okay, so you're going to have different scenarios. One scenario is you get an ordered triple for an answer. Okay, that would be like number 3 and number 1 that we worked together. You get an ordered triple. That happens. You could also get a false. All your variables cancel, and then what you're left with is not true. So there's no solution. Or the third case, everything cancels and it's true, so you have infinitely many solutions. Okay? Does that give you enough information to do your homework? Okay, carry on.